Let's take a look at 2.4, just part 2. We'll look at amplitude and vertical shifts. So first thing is, what is the amplitude of a sine or cosine wave? Okay, well, the amplitude is the height. Okay, it's a height. And the way you measure the amplitude is from what we call the center line to the highest point. Okay, that's the amplitude. It should also be symmetrical from the center line to the lowest point. And the amplitude is strictly that height off that center line. Okay, since it's an amplitude, it's a height, what kind of number does height have to be? It has to be positive, right? There's no such thing as having a negative amplitude. Okay, amplitude, if I ask you, what is the amplitude of this function? You should be giving me a positive number. And what does an amplitude change look like? Okay, an amplitude change is when you have a function, sine or cosine, and you multiply by a number in front. There's an example. 3 sine x. Yep. Okay, so now next thing I want to do is figure out what did this 3 just do. Okay, so it's going to change the height. It's going to change the amplitude. Okay. What do you think the 3 is going to do? Is it going to make it bigger, or is it going to make it smaller? Bigger? Anybody think it's going to make it smaller? All right, so you might have a reason to think that, because yesterday we did the phase shift, and it was the opposite of what you thought. Today it's not. Okay, today it's pretty much going to do what you would expect. Right, so if we graph sine of x and 3 sine of x. Okay, there's the original. And there's 3 sine x. Okay, so 3 sine x does triple the amplitude. Makes it 3 times as high. All right, any question on that? So what would that be in terms of a sound? What do you think that would affect if you played the blue and you played the red? What would the difference be between them?
Volume would be higher.
Volume. Yep. So it would sound the same pitch. It didn't change the frequency, but you change the volume. Okay. So if you play that, and then you turn it up. Really, I need 2 speakers to show it to you because I have a left and a right, and I only have 1 speaker. But if you had 2 speakers, the left one would now sound louder than the right one. All right. So that's what happens when you stretch, or if you compress it. Kind of hear it a little bit. It starts to get softer. Okay, it's the same idea. So stretching or compressing changes the volume. Okay, what about if we tied that into electromagnetic waves? Do electromagnetic waves have volume to them? Like X-rays. Is there such thing as the volume of an X-ray? What do you think, Adam?
Sure.
You hear X-rays?
No.
No. X-rays, remember, X-rays are electromagnetic waves. You don't hear X-rays, okay, any more than you hear light. You don't hear light, you see light. All right? So, any guess what would happen if you change the amplitude of an electromagnetic wave? Like pretend the red and the blue were both X-rays. What the difference would be between the 2 X-rays? One would be stronger, exactly. So the idea is it makes the signal stronger. What does stronger mean? Depends on the type of wave. Could mean louder, if it's sound, or it could just be stronger in terms of the X-ray can go through more material. Okay, it's a higher power X-ray. Okay, there's another example of a amplitude change. Okay, and the last one is also an amplitude change, but it's going to compress. Now, the negative here does something. Okay, the negative has no effect on the amplitude. Okay? So if I got rid of the negative and gave you this problem, negative 2 cosine x and positive 2 cosine x, there's no difference in the amplitude. They have the same amplitude. All right. But when you actually draw the picture of it, the negative is going to change the picture. Okay? So that's important to understand. Negative won't affect the amplitude, but it will affect how you draw it. Okay? And we'll go through that. And the reason it doesn't affect the amplitude is because if you want to know the amplitude, you take the absolute value of the number in front. Right, so the amplitude is always positive. Okay, we already said that. All right, so let's say I gave you a problem like y equals 3 sine x. Okay, what's the amplitude of y equals 3 sine x? 3. Yep. What would be the amplitude of negative 2 cosine x? 2. Right? What would be the amplitude of 2 cosine x? It would still be 2. Same thing. How about someone else? What's the amplitude of half sine x? Josh?
Half sine? Or half?
Yeah, it's got to be a number, just a half. What would be the amplitude now?
Half.
Still a half. Okay. The negative is going to change the picture, but it doesn't change the amplitude. Okay. So we already saw basically what's going to happen here. If the number in front has an absolute value greater than 1, it's going to stretch it. 5, 12.2, negative 18, all those numbers are going to take your graph and stretch them. If the number in front has an absolute value of less than 1, 1/3, 1/2, negative 2/3, okay, all those numbers would have absolute values less than 1, then the graph is going to compress. All right, so I didn't show you a compression, but that would be a compression. Took the blue wave and it cut the height in half. Okay, 0.5 sine x. Hey, any question on that idea? When a graph is going to stretch or compress?
Can you go back?
Yeah. So what's going to happen is now we need to figure out the 5 key coordinates. Okay, where are those 5 original points going to move to? What's going to stay the same here?
X.
Yeah, x is going to stay the same. Okay, when you're doing a amplitude change, you're going to stretch or compress it on the y-axis. So this time we're not changing the x's. And when the x's don't change, things are a lot easier arithmetic-wise. Why? Think about what the x's are. Those are all the zeros, pi over 2, pi, 3 pi over 2, all those numbers that are a pain to work with. We're not going to have to change any of those numbers this time. Okay? The y values, those are the easy numbers. They're all zeros, ones, and negative ones. All right, so if all we have to do is do arithmetic with a 0, a 1, and a negative 1, it's going to be very easy. Very easy. All right, so copy down your x's. Those stay the same. Now we have to find the new y values. All you have to do is multiply what the old y values were by a, which is the number in front of the sine or cosine function. Okay, so to find the new y values, just take all the old ones and multiply by whatever the number was in front. Notice here, I didn't write absolute value. It's not the absolute value. It's whatever the number is in front. If the number is a negative 2 in front, you're going to multiply all the old y values by negative 2. And that's it. Those are the only 2 steps. Okay, any question on how we're going to find the new y values? All right, so let's try one. Okay, so it's 3 cosine x. Okay, before we even really start to look at this problem, what would be a good idea to write down or look up somewhere? Yep, the original. Okay, if we don't know what the original is, we're not going to know what the new one is. Okay, hopefully by now you're starting to get used to those x values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now it's the y values. We're going to be careful because they're different for sine and cosine. Okay, Zach, where do my y values start for cosine?
1.
Yep, they start up at 1, and then it goes down from there. Goes down to 0, keeps going till it hits its minimum, starts heading back up, and then finishes where it started. Okay, so that's your original table. Now we need y equals 3 cosine x. Now we have a little bit of a choice. We have a few different, couple different transformations we know. We know phase shift, and we know amplitude change. We have to figure out which one this is. Okay, Sean, what kind of transformation is that? Is it a phase shift or an amplitude change?
Amplitude?
Yep, and how do you know it's an amplitude change and not a phase shift?
Because there's nothing in parentheses, right?
You're not adding or subtracting something to the x value in parentheses. That would be a phase shift.
Yeah, that's kind of
Yep.
same.
Good. All right, so we know it's an amplitude change. So what is going to stay the same? Yeah, x will stay the same. We're going to change the height. Okay, height, that's a vertical thing. That's y's. Y's are going to change. X's won't. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, now to get the new y values, take all of the old y values, and we're going to multiply them by a. Okay, Andrew, what's a in this case? 3. So take all your old y values and triple them. Okay, so Max, what would I get for y values if I do that?
Yeah, 3,
Yep.
0, -3, 0, 3.
3. That's it. That's your table. Any questions on how we got those values? Now we're going to graph it. So when we graph it, okay, what we're going to do is we're going to scale our axes the way we need to. Okay, x-axis, I'm going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Every single problem tonight should have this as your x-axis because you're not shifting left and right. So there's no reason the numbers on the x should ever change. Okay, now on the y-axis, Lydia, what's the highest y value I have? 3. And the lowest y value? -3. So what I did is I just changed the scale on my y-axis to go by 3s. The highest one is 3, lowest one is -3. If you want to draw it in like this, 1, 2, 3, you can do it, but it's not necessary. All right, so graph your points. 0, 3, 0, -3, 0, and back to +3. And it basically looks exactly like the original. Okay, why? Because I changed the scale on my axes. In fact, if I wanted it to be the original, all I'd have to do is go like this. Now it's the original. Okay, if I had a problem that said graph y equals 6 cosine x, okay, to do that, I could just change those two numbers. 6 to negative 6. Okay, so my point here is, depending on how you scale your axes, a lot of these problems are going to look the same, especially if you change your scale for every problem. Okay, any questions on why this looks just like the original? All right, here's a amplitude change. Let's try this one. Y equals half sine x. Okay, let's see if we can do this one. See if we just remember the original table without having to write it this time. Okay, Andy, what kind of transformation is this? Yep, that's an amplitude change. So when we have an amplitude change, how about Sam? What stays the same? X is going to stay the same. All right, so we got 0, pi over 2, pi over 2, 2 pi. Okay, and how about Amy, what kind of amplitude change do you think this is? Is it going to make the graph stretched out more or compressed? Yeah, it's going to compress it, okay, because the number in front is smaller than, absolute value is smaller than 1. All right, so anybody think they can tell me what my new y values will be, the final answers? Yep.
0, 1/2, 0, negative 1/2, 0.
Good. Any questions how she got those? Yeah, the originals would have been 0, 1, 0, negative 1, 0, and she just took half of all. It's perfect. Right, now we'll make your sketch. Actually, I already have my axes. This time I'm going to scale it so that my highest value is 1/2. And the lowest value is negative 1/2. Sometimes when you put in your labels, your graph ends up going over the labels when you can't really help that. And if you do that, that's fine. Zero, 0, up at 1/2, 0, negative 1/2, back to 0. Okay, there's our sketch. Any questions on that one? All right, so let's try one more with amplitude that's a little different. Y equals negative cosine x. Okay, first question I'm going to ask is just what is the amplitude of that function?
1.
Well, amplitude has to be positive, so
1.
just 1. Yeah, the amplitude is 1. What's the amplitude of the original? Just y equals cosine x.
So 1.
That's still 1. So I haven't changed the amplitude here. But the reason I'm doing this problem under the amplitude change section is because there is something in front. Okay? It's a negative. But what number is there if we don't see it? Yeah, it's a negative 1. Okay? It wouldn't be written that way on the test. It would just be written as negative cosine x. But if you want to think of it as being a 1, that negative 1, that's fine. So the amplitude here is not really going to change, but something's going to happen. Any thought what that negative is going to do to the graph? Well, it's got to do something, right? Because having a negative there is different than not having it. So since that negative's there, it's going to do something.
It's gonna, like, on the graph itself, it's gonna go down instead of up at first, from 0.
So it's going to go, so it goes down normally and makes kind of a U shape.
Yeah.
So what's going to happen?
Like, on the table, it's going to be like 0, -1, 0, 1, 0.
Okay, so anybody explain what's going to happen from the original? So that's,
What?
yeah, it's going to flip it, exactly. It's going to flip. That's what a negative does. It causes the graph to flip over the y-axis. Okay, so x's are going to stay the same. And all your y values are going to get multiplied by -1. Okay, so normally you'd be starting at +1. Now you're going to start at -1. The next value would have been 0. I'm going to multiply 0 times -1. It stays the same. Okay, next value would have been -1 normally. Times -1 becomes +1.
Oh, yeah, it's gonna sound.
Okay, next value is 0. Multiplied by -1 stays 0. The last value, normally it would have been a +1. Multiplied by -1, and you get -1. Let's see what that looks like. Technically, this time, do I need to label my y-axis? No, why not? I'm going to go by ones. If you don't label it, I'm always going to assume you're going by ones. So -1, 0, 1, 0, -1. Okay, so it would be something, if it kept going, it would look like that. Okay, you just have to draw the part that's solid. Sometimes I draw the dotted line just to try to get an idea of the curve of the graph. And that's it. Okay, that's for what happens when you have a negative in front. Okay, so both of those types, whether you have a negative in front or you don't, that falls under the amplitude. Okay, so the last type of transformation that affects y values is a shift. Okay, a shift doesn't stretch anything. It just takes what's there and moves it. Okay, I can't do a shift on the frequency generator because there is no connection with what we're about to do with sound. Okay, but visually, this is what a shift would look like. Okay, which being drawn in blue, that'd be your original. And then a shift would just take exactly what's there and move it up, or it could move it down. Okay, that's what a shift looks like. And a vertical shift has the form of sine of x plus or minus, and I just use the letter d. Now I thought a phase shift did that. A phase shift also had plus or minus. What's the difference between phase shift and vertical shift? Yeah.
On the other one, the plus was inside the parentheses.
Right. That's the whole difference. Okay. Are you doing a plus like that? That's a phase shift. Or are you doing it like that? That's a vertical shift. What if I put parentheses around the two? That doesn't change anything. That's still a vertical shift. Okay, so we already kind of graphed it, so we can probably guess what's going to happen. If you do plus, it shifts up. If you do a minus, it shifts down. So this is the other transformation that works the way you would expect it. You don't have to do opposite. And that usually confuses people. They'll see a +2, and they'll say, oh, it's going to shift it down 2. And I say, well, you're mixing the idea up with a phase shift where you got an opposite. No, you don't do opposite here. So a vertical shift will move it up if you add, down if you subtract. Since we're going to be shifting up and down, which values are going to be affected here? Are the x's or the y's affected? Which ones? Well, think about which axis goes up and down, x or y. The y-axis goes up and down, and you're going to change the numbers that go up and down. We're going to shift it up and down. So the y's are the ones that change. X's stay the same. That's the first step in figuring out where those 5 original points, those 5 key or 5 important coordinates, where they're going to go. X's stay the same. How about the y's? Based on what we just did for amplitude change, anybody have a guess what you're going to do to get your new y values? Yeah, all you're going to do is add or subtract something to them. What are you going to add or subtract? Well, whatever d is. If d was a plus 2, you'd add 2 to all the old y values. If d was a minus 5, you would minus 5 from all the old y values. But this should be very easy arithmetic to do because you're adding and subtracting from 1s, 0s, and negative 1s. So it's not overly hard arithmetic. Right, so let's look at an example. Sine of x plus 2. Let's see if we can go right to the final table again without writing down the original one this time. Okay, Brandon, what values are going to stay the same?
The x's.
The x's, so we're going to copy those down. Okay, how about Ben? Can you give me my x's? Ben? Okay. What are my standard x values? What do they always start off with? Yeah.
Sorry. 0, 1.
Okay, starts off with 0. And now the x's, those are the ones with the pies. Yeah.
Pi over 2.
Pi over 2?
Pi. 3 pi over 2. 2 pi.
Right. 3 pi over 2 and 2 pi. It's just down. Now we need to find our y values. Okay, if you are confused and you need the originals, they would have been 0, 1, 0, negative 1, 0. Okay, we're going to take each one of those and we're going to add 2 to all of them. Okay, so Olivia, what will my new y values be?
2, 3, 2, 1, and 2.
2. Yep, just plus 2 to every one of those. All right. And that's it. That's your table. Okay, so 1 point for, just like we did before, for each x and y value. A couple points for getting the sketch. Okay, this time, I'm not going to scale anything differently. I'm just going to go 1, 2, 3. Now, if I shifted it up by, say, 20 units, then I might want to change my scale or even use a break in the graph or something like that, but this isn't that much of a shift. And let's graph our points. So 2, 3, 2, 1, and 2. Okay, what's the amplitude of that? Okay, or 2, 3, and 1. Right, all different options. So the amplitude would be the height, if you had that center line drawn in. How high does it go off that center line? Just 1. Okay, if I draw it in, there's the center line. Okay, and the amplitude is the height above or below. It should be the same. 1 unit. Okay, so that is not an amplitude change. That's just a vertical shift. And we'll finish up with this one. Okay, cosine, y equals cosine x minus 5. Okay, this time I have parentheses around cosine x. I wrote it a little differently. Is it a phase shift now? No, why not? Yeah, that minus 5 isn't inside with the x. Okay, so there's many ways you could see this written like this as well. Same problem. Okay, this is also the same problem. Could be written any of those ways. A lot of people try to do a phase shift with that on the test, and then they get very confused because they're like, wait a minute, we've never done a phase shift with a 5 before. We've always done a phase shift with like a pi or a pi over 2. So if you start doing something that we've never done in class, chances are you're making a mistake. So that's a vertical shift down 5. Okay, so my x's, keep them the same. And my y values are going to go down 5 units from where they would have been. Okay, Cody, where does cosine start for y values? Yep, starts up at 1. I'll just write it off to the side in case you need it. And now take and subtract 5 from all those values. Okay, so Naisha, what would my first y value be? You're subtracting 5, yeah. Yep, from your original y values. Yep, so negative 4. Next one. Okay, keep going. So what happens? You have negative 1, take away 5. Anyone help her out? What does that give me? Yeah, negative 6. So think if you take away 1 and then take away 5 more, now you've taken away a total of 6. Okay. Then we're back at negative 5 and negative 4. All right, so this time I decided just to put a grid in so I could draw it a little easier. Okay, label. This time I'm going to label up above the axes. That way I don't have to write in my grid, and if I draw down here, it won't get messed up with my numbers. So pi over 2, pi, 2 pi over 2, 2 pi. All right, and we're at negative 4, negative 5, negative 6. And I didn't label my y-axis because I'm going by ones, but it might not be a bad idea. So you don't get confused. Back up to negative 5. And back up to negative 4. What's the amplitude of that function? 1. Didn't change. Okay, unless you stick a number in front, amplitude's not changing. Okay, so that's a vertical shift. Any questions on those two transformations? So the only transformation we have left is when we start stretching or compressing on the x-axis, and now we can do some much more interesting things sound-wise. So tomorrow I'll show you what that does, and I'll show you some things you can do with frequencies and controlling a cell phone by playing certain frequencies. And I'll show you some, maybe a little bit of uses in music. Okay, talk about some songs and maybe some military uses for sound frequency changes. Right? So there's a lot of different things we'll look at. Okay, so the homework tonight will be very similar to last night, just a worksheet.